Welcome students, let us discuss a very interesting topic from the chapter sets, and this topic is Venn diagram. Okay, this is called Venn diagram. So what is Venn diagram? Venn diagram is a pictorial notations of sets and simple operation of sets. Okay, so how to represent sets diagrammatically, that we can see in this topic, Venn diagram. So we know universal set is a superset of other sets in that particular context, and superset is the biggest set, and this superset is denoted by a closed diagram, most preferably a rectangle. So superset, or you can say universal set, is represented by interiors or all internal points of a rectangle like this, and you write here in the right top corner U for universal set. Okay, and other sets are subsets of this universal set. So all the subsets of this universal set are represented with the help of a closed geometric diagram, maybe circle or maybe some oval shape like ellipse, like this. Okay, suppose this is set A, and another set B can also be represented with the help of a closed circular diagram. So all internal points of that set A represent set A, and all internal points of another set B represent set B, like this. Okay, suppose set A consists of two elements, or suppose four elements A, B, C, D, and set B consists of four elements C, D, E, F. Okay, so what you see here, we see that some of the elements are common in both the sets A and B, and these common elements, which are the common elements here, C and D are common elements. So if we place these elements of these two sets in this diagram, then these common elements will be placed in the common area, which is common in both the sets, both the circles. So we'll write here C and D in the common portion of these two sets A and B. Other two elements of set A are A and B, so we can write here these two elements A and B. And similarly in set B, as C and D are common elements, E and F are other two elements in set B, so we can write these two elements here. So in this way we can place all the elements of this set suitably in common portion or non-common portion. So in this way we can represent a set diagrammatically. So Venn diagram is nothing but to represent a set, or you can say this is a representation of sets diagrammatically. Not only sets can be represented with the help of this diagram, which is known as Venn diagram, we can represent some simple operations on sets that we will see in next video here. So we can represent operations on sets using this Venn diagram. As for example, suppose we want to represent A union B. Then what is this operation, A union B? A union B is the total sum of all the elements of set A and B. As for example, here A union B will consist of, let us write here, will consist of all these elements available in either set A or set B. So this will be A, B, C, D, E and F. You know, A union B. This is a kind of operation on these two sets A and B. And as we discussed, AUB is nothing but collection of all the elements from set A and B, whether these elements are available in A or B or in both, in common. And this A union B operation on these two sets A and B can be represented diagrammatically using Venn diagram like this. We'll write in the right top corner U for universal set. This is set A and this is set B. If you want to mention these elements, then as we discussed, here we will write A, B, C and D are common, E and F. And here we will write A union B. Okay, so sometimes for sake of convenience, sake of simplicity, sake of understanding, we can shed of the portion of these two sets which shading area will represent this operation A union B. So A union B means sum total collection of all the elements or collection of all the points in these two closed sets. So if you want to shade this area, this will be shaded like this. So this shaded area is showing this operation A union B. It will not should go outside, it will remain inside, okay, like this. So this shaded portion of this area is representing this operation A union B. Similarly, if you make an operation of these two sets A intersection B. A intersection B means common area, common elements. So in respect of these two sets A and B, which elements are common? Only C and D. So this will be C and D. And how we can represent A intersection B? This is known as intersection, this is known as union, this is just opposite notations, reverse of this is this one, okay. So A intersection B can be represented diagrammatically using Venn diagram in this way. This is universal set, okay. This is set A and this is set B. If you don't write common elements, even then we can make shading of the common area, and this shaded area is showing which operation of these two sets? A intersection B. And if you wish to write all the elements like here, then no problem, we can write here A, B, C, D, E, F. So C and D are two elements in common part of these two sets, or these are common elements. Okay, so these are some very simple representation of sets using Venn diagram. Suppose we want to represent A minus B, then A minus B will be how much? What are the elements of this set A minus B? Means from this elements, this set of A, we will delete, we will remove, we will omit all the elements which are available in B, which is known as A minus B. Means CD is available in both the sets, so CD will be removed from set A and remaining elements will be simply A and B. And the Venn diagram for A minus B will be like this. This is universal set, this is set A, this is set B. So A minus B means the portion which is available in B has to be removed from set A. So A minus B is this shaded portion only, which will consist of these two elements only, A and B. Very simple. Similarly, if we have to represent B minus A, then the common elements will be removed from set B. We are doing B minus A. So simply this will be E and F. And how we can represent? This is universal set. This is set A. This is set B. So B minus A means the portion of A which is common with B will be removed. So only remaining part will be this much. Okay, this is representing B minus A. So you make clear very clearly, this is A minus B, means portion of B has been omitted from A, and this is B minus A, portion of A is being omitted from portion of B. This is B minus A. So these are very simple and basic operations on set which we are representing with the help of Venn diagram. Suppose you have to represent A is a subset of B. You have to represent it diagrammatically using Venn diagram. Then we will draw this universal set as a rectangle. Here A is a subset of B. So we have already discussed this set A is subset if all the elements of set A are available in B. So set B is a bigger set. It may consist more than elements of set A. Okay. So here B will be like this. This is set B and this is set A. So entire area of set A will lie inside the closed area of set B if A is subset of B. And conversely, if B is a subset of A, then we put B inside A. Correct? So in this way we can represent subset notation also with the help of Venn diagram. Suppose we have to represent Venn diagram about disjoint sets. Disjoint sets. If two sets, suppose C and D are disjoint sets, disjoint means no element is common, no point is common, no area is common. These two sets are totally different, entirely different. So these disjoint sets can be represented with the help of Venn diagram in this way. C and D are two sets which are disjoint. So C will be here one set, D will be here another set. No area, no portion is common. So this is representation of two disjoint sets C and D using Venn diagram. Correct? So in this way we can understand how to represent sets and operation of sets using Venn diagram very interestingly. Now in the next video we will see some more operations on sets and some exercises, some problems related to this topic. So please keep watching these videos and enjoy learning mathematics. Thank you very much.